So both Rob, Patrick, and Elise touched on the topic of fair, right, in their presentation. So now I thought, let's hear a little bit from the others. Does fair play a role in your work as well? I see Mireille is nodding.
Yeah, it's playing every day a role. Yeah, we need to find and access our data we are generating, and also sending them out to the colleagues. They must be reusable, usable and reusable. But the main challenge for me is always the interoperability of data.
Mm-hmm. Yeah. What the other thing is, what is the hardest of the principles to implement?
Certainly, from an integrator's point of view, I would echo that. Interoperability is a challenge. You just look at plate readers, for example. From each different manufacturer, that data is just ever so slightly different each time. And yeah, they may be using XML, but the way that data is constructed within the file, and then it falls upon us as integrators often to help out, get that into a format which allows us to move that data downstream somewhere else. And while everything's possible, again, it's that phrase, reinventing the wheel. It feels like we're doing that every time. So interoperability is definitely a big one.
Having data which is not just stored somewhere, but is really also usable, not by the person that he knows where it is and it's just in the brains. This is the main thing. So if you have about 20 Excel sheets, it's okay. But if you have a history of 10 years with different formats, with everything, you end up in hell. And so you need a concept. I'm really sign up on this. Yes, absolutely.
I think one of the biggest challenges, though, for digitalization is actually people and the change and the change element to it. I think you're asking people to do things in a slightly different way to what they're already accustomed to. And sometimes you need something big to happen for there to be a seismic change, like a pandemic, for example. Right? That really has changed the way that we're looking at running experiments within labs and how we capture data if we're not necessarily there actually in that lab at the same time.
You need to show regularly to people what is possible, and then they catch on and they get the ideas, and they want to adopt that little piece also to their work. But it goes slowly. They need to adopt, get their appetite wet, and then they continue. And it needs to come from everybody and not only from me as a lab manager.
So one thing that I see is that the range of techniques is expanding. There's a great amount of innovation at the level of the instrument company. So I touched on startups as well, bringing in new ideas. There's new devices, new degrees of automation, and that presents new challenges. We've got combinations of techniques to understand better and more quickly and with high throughput these more and more sophisticated samples. You look at the BioNTech vaccine, it's a really complicated little thing with RNA and then 4 types of fat. There's quite a lot of things to go wrong. So the quality control and the planning and the design needs to be done with more sophisticated tools. So we're always running to keep up, which means we need the dialogue between the standards, the community, the users, and the developers of new techniques and academics, so that we keep going, because we can't stay still.
Is a human better than a robot?
Yes, humans of course are better than robots, right? Because humans have personality, but they can react as well. Okay, so humans can react to a situation, but they might not necessarily follow the same process each time. And that's where a robot has a benefit. But that's changing. There's a lot of research going into making robots a lot more reacting to the environment that they're in. I guess one day we'll have an automated system which absolutely cannot mishandle a plate, but unfortunately, I guess the problem for automated systems is humans are involved, right? If they don't load up the system properly, you'll get errors. So I don't want to blame humans too much.
Why do you think it is important that scientists can by themselves couple devices and software? You said that in your talk.
So for me, it's a question of agility. So if you have the freedom to automate things so that you can in that time do some other things, you will just boost up your productivity. So at the moment, we're in a state where we say, I have to measure this plate, I have to change the conditions, I have to have a different dilution series, so I will just do it by hand. And this is a good choice for one time. There's also a good choice for 2 or 3 times, but if you do it more often or more daily, an automation which would be as easily, let's say, controllable as a lab colleague, which you can say, do me 10 plates with this dilution series, would just free up your time. So what you would do, you would just orchestrate together the different devices, let the work be done by the robot or by the machines, and do some other things. So it's a thing of time saving. So we're not talking about people running around there, nothing to do, but these are highly educated and highly paid biologists and chemists and technical assistants. So they should do other things than be the servants of machines, I guess.
I may add one point to that. People know their data, but they often don't explore their data enough, and especially in visualization. And there, I often like to use Knime, put on different visualization nodes and show them the people, oh, look, isn't that nice? Or could we do that or that? So this exploration phase is also something really nice on our data, which had not yet been exposed to different visualizations.
That's an
Right.
excellent point.
Yeah.
The hidden potential.
Yeah, it's so powerful.
A big, big thank you to our great speakers and panelists. Cheers.
Cheers.
Thank you.
Cheers.